Okay, section 8.1.3, stretch factors of polynomial functions. Problem 8-39, write reasonable equations for each of the following polynomial functions without using a graphing calculator. How can you check the accuracy of your equations? Were all your equations accurate? If not, why do you think your equations were not accurate? So this is all about writing the exact equations. So we're going to want to start with the roots, or the x-intercepts. So I can see it hits at -3. I'm just writing them at the bottom because that's where I have space. 0 and 2. So if those are my roots, put them back in factored form. That's x plus 3. And it's going straight, so it doesn't have an exponent, or it has an imaginary exponent of 1. X is just x, 0 is just x, and it's going straight through also, so exponent of 1. And then positive 2, opposite, gives me -2. It's also going straight through, so make sure you look, right? These are straight through right at those intercepts, so that's why all my exponents are 1. Now, what we want to do to make sure it's accurate is we want to use another point that's given. So this appears to be the point 1, -4. So using that, I have y equals, well, I guess before I use that, a, and then I like my x in the front, times x plus 3 times x minus 2. Now I'm going to use that. Y is -4, a, x is 1. So I'm going to make all my x's 1. I'm using that green point, times 1 plus 3 times 1 minus 2. So -4, a times 1 times 4 times -1. Too many negatives. -1. So -4 equals, that multiplies together to be -4a, divide by -4, and in this problem a is 1. So my equation is f of x, or y equals, whatever you prefer, imaginary 1, but I'll write it this time, times x plus 3 times x minus 2. But what they're looking for is that you find that a value, and it's not always going to be 1. So let's look at the next one. Okay, start with the roots. I see a root at -3, and it's going straight. Then I see a root at 0 again, but that one's got a cubic look to it, so we'll take that into consideration in a minute. And then 2 again, looks like they're using the same roots. But now, those were my roots. As factors, I have x plus 3, and it was straight, so that just stays like that. Then I have that single x, but because it looks like a cubic, that needs a cubed. And then I have my plus 2 becomes x minus 2. Find that other point they gave you. This point looks like it's -2, -30. And this time I'm going to plug that in at the same time. So -30 equals a times, I'll just keep them in the order they're in now. X is -2. -2 plus 3 times -2 cubed times -2 minus 2. So I plugged in x, y, and remember you're solving for a. -30 equals a times 1. -2 cubed is -8. And -2 minus 2 is -4. So -30 equals -8 times -4 times 1 times a. It's going to be 32a. Divide by 32. This function, f of x, is -30 over 32. Again, I'm going to move my x's in the front because that's where I like them. X cubed, x plus 3, x minus 2. So this one had a stretch factor. Also, it comes out to be negative because that right tail is going downwards. See if you can do C. My roots. I see at -2, but it is a bounce, so we'll have to square that later. And at 1. So my factors, opposite, x plus 2, and to make it bounce like that, it needs a square, and then x minus 1. Do they give us a good point? looks like this point at the top is 0, 8. So I know 8 equals a times 0 plus 2 squared times 0 minus 1. 8 equals a times 4 times negative 1. 8 equals negative 4a. Divide by negative 4. A is going to equal negative 2, which makes sense because that arrow is down. So this one is negative 2 times x plus 2 squared times x minus 1. Okay, 8-40. What's the difference between the graphs of the functions just x squared times x minus 3 times x plus 1 and 3x squared times x minus 3 times x plus 1? So they're going to have the same roots, but this 3 is going to give it a vertical stretch, just like it does to parabolas and everything else you've been doing. That's the only difference. Are the intercepts enough? Melvin wrote the equation to represent the graph at the right. Explain how you can decide whether the equation represents the graph. What can you do to the equation to make it better fit? So let's see. He's got his x plus 3, which is straight, so that's good. His x plus 1 straight, and then his x minus 2 bounce. So it looks good. The only thing he needs to do is he needs to find the stretch factor. Do they give us any good points? Let's see. What can you do to the equation to make it a better fit? What equation would fit better? So we know it's going to have a stretch factor. If we look down at B, they kind of set you up for this. The polynomial is written with an A in front of it. And then what if we told you, because the graph isn't the greatest, but we give you the equation in writing, the point in writing, right? So we would have 16 equals A, x is 1. So 1 plus 3, 1 plus 1, 1 minus 2 cubed. Pause the video and see if you can solve for A. Well, hopefully you noticed my mistake. It wasn't cubed, it was squared, right? So make sure you write the equation down the way it's supposed to be. So this equation, to make it more accurate, is going to be 2x plus 3, x plus 1, x minus 2 squared. Solving for A. 842, the county roller fair coaster ride. Now that you have more experience with polynomial functions and their graphs, the Math America Land Carnival Company has hired your team to write the exact equation to represent the roller coaster below. The numbers along the x-axis are in hundreds feet. At 250 feet from the starting point, the track will be 20 feet below the ground. So that's this point that they gave us. What degree polynomial can be used to represent the portion of the roller coaster? Okay, so let's see. It hits once there, then it has a double root there, and then it's going to go straight through there. So 1, 2, 1 are going to be the exponents. So if I add those together, it's going to be a 4th degree. What are the roots? So there's a root at 0. There's a double root at, I wrote all over it. I need to erase this so I can see it. There's a double root at 2 with multiplicity 2. And then there's a root at 3. Write an exact equation. So y equals a. We've got a root at 0, so x. We've got a double root at 2, so minus 2 squared. And we've got a root at 3, so minus 3. And then we know that other point given up at the top. Negative 0.2 equals a times x is 2.5. X is 2.5. And x is 2.5. You're going to need a calculator to finish this. Okay, so I took out a calculator and I finished the math. A comes out to be 0.64. So we have 0.64 times x minus 2 squared times x minus 3. What is the lowest depth of the roller coaster's tunnel? So if we look at the graph really closely, it looks like the lowest point happens around 0.6. So you're going to want to plug in 0.6 to the x's to get the lowest point. Again, you're going to need a calculator. So to find the last answer, plug in 0.6 and see what you get. When I plugged it in, I got negative 1.35, but remember that's 100 feet, hundredths of feet, so below ground 135 feet. Some polynomials have a stretch factor just like the a in the equation of parabolas. Okay, write the exact equation. See if you guys can do this one. Pause your video and try it on your own. Hopefully you were able to follow along with everything I did there. Okay, 44. Write a polynomial equation for the function with a graph that bounces off the x-axis at x minus 1. Let's just do this one at a time. Bounces the x-axis at negative 1, 0. So that means x plus 1, and bounce means squared. Crosses at 4, so that means x minus 4 because it's opposite, and crosses is just straight. And then it also goes through that point. So right now we have y equals a in front of this. This is the point I keep making green for some reason. So negative 18 equals a. X is negative 2. X is negative 2. So negative 18 equals a times this is negative 1 squared. This is negative 6. Negative 1 squared is positive 1 times negative 6. So this is negative 18 equals negative 6a. A is going to equal 3. So y equals 3, x plus 1 squared, x minus 4. Armando comes up with the equation given for 44. Does his equation fit all the criteria? 3x plus 1 squared, x minus 4. 3x plus 1. Oh, he is to the 4th power. Does the equation fit all the criteria? Why or why not? So because they tell us it bounces at negative 1, if you were to graph x to the 4th, that does technically bounce. It's not likely that they meant x to the 4th, but it is a possibility. Even exponents bounce. So it does fit all the given criteria, and it's a little different than the one we came up with. We would need to know one more point to make sure both of our equations go through it. What if 44 to the polynomial equation of degree 3 and the graph went through this point? So here's 44 again. We had degree 3, right? So we got that part set up correctly. So we're going to steal that part. A, x plus 1 squared, x minus 4. But now they give us a different point. So negative 36 equals a. X is 1. I need to go back just to make sure I wrote that down right. Plus 1 minus 4. Okay. And then solve for a. A and ends up to equal 3 in this case, which I believe is what we had originally. Yep. So with a little more information and specifically knowing the degree, we know we did it right. So based on that, what information about a graph of polynomial is necessary to determine exactly one correct equation? So the degree, the roots with multiplicity or behavior, however you want to look at it, and then another point. Okay, hopefully that's the end, right? Yep, hopefully this helps.